and believes that the best is yet ahead. So without further ado, I will stop sharing my screen and introduce and turn it over to Bob. Bob, you have the floor.
Hey, thank you, Glenn. And you are absolutely rocking that bow tie in that photo, my friend.
Thank you, sir.
Outstanding. Love it. And thank you so much to everybody who is joining us today. I absolutely hope you are safe and well during these crazy, chaotic times. And I also want to give a big shout out to Costa and the AQAA team for putting together just a great lineup of speakers. And I am flattered and honored to be included among the lineup. So today we're going to talk about rapid risk analysis in an Agile and DevOps world. Again, my name is Bob Cruz, CEO and co-founder of Checkpoint Technologies. A little bit about myself. I have been in IT now for about 32 years. Started off as a COBOL IBM programmer, started my IT experience in the Air Force, and then went into the commercial world. And I was very passionate about development and databases and whatnot. But then in the late 90s, I developed a real passion for test automation, risk analysis, and just pretty much quality assurance and software testing in general. I am also a president of TBQAA, Tampa Bay Quality Assurance Association, which is part of QAI worldwide. I've taught numerous CSTE prep courses, so I'm sure many of you are familiar with that. And I'm community director on Vivid, which is an independent software user group. And I'm co-leader of the Vivid group here in Florida. So just a little bit about myself. And, you know, one of the things, and Glenn, I know you'd agree, we love questions. So feel free to submit any questions during the discussion, but we'll also have time at the end. So what we're going to talk about today are why is it you can't test everything? So we'll talk a bit about that. I'll talk about the value of performing risk analysis. As Glenn mentioned during the intro, I have consulted and I've trained for well over 200 organizations, and it has always amazed me at the number of organizations not doing any sort of risk analysis. So I'm going to talk about the benefits and the value of those benefits. And then I'm also going to talk about ideas on how to implement and improve your testing by implementing risk analysis. So some great stuff to talk about. So, you know, you cannot test a program completely. It just isn't possible. From a great book titled Testing Computer Software, there are 3 reasons listed why you really cannot completely test any application or system. For one thing, the domain of possible inputs is way too large. Now, a number of years ago, I was a developer and then a QA analyst on an FBI project for NCIC, National Crime Information Center. And one of the many business units I was responsible for were VIN edits. So VIN is in vehicle identification number. Now, for those of you that are not familiar with your VINs, take some time and really get to know your VIN. It is a 17-character number, or at least it has been since 1981. Prior to that, it could be 8 to 10 characters. But since becoming a 17-character number, it is made up of, and I use the term number, but it's made up of alphas and numerics. And those numbers are positional and indicate the country of origin, the make, the model, and all sorts of information. I saw a great article that compared a VIN to a DNA of vehicles. But the thing is, as you can imagine, to have 17 characters, a 17-character string, and testing edits for both valid and invalid VINs, there are millions of possibilities, conditions I could easily come up with. There was no way in the world I was going to test everything possible with a VIN. Another reason, too many possible paths through a program to test. For those of you that are developers that have done programming, you will know exactly what I mean. in any true-false condition, that right there is two different scenarios or two different conditions. Now, if under each true-false, you have another branch or condition, then you could have a true-true, true-false, or a false-true, false-false. So as you add branches and conditions in different scenarios, you then just extrapolate and continue to increase the possible paths through the program that we've got to figure out how to validate. Then a third reason is user interface issues are just way too complex. Now, I'd be willing to bet you there are many of you in the audience that have been in IT for 25 or 30 years. And you can remember when the vast majority of user interfaces were block screen, the green screens. You had nothing but fields and screens. That was it. Then as IT and user interfaces evolved, we ended up getting pop-up windows, drop-down list, and edit fields, push buttons, check boxes. Now we're at the point with mobile devices and smart devices where they have facial recognition, they have fingerprinting. I imagine the day for those of you that are old enough to remember I Dream of Jeannie, where you will look at your phone and you'll do something like that and the whole head nod, and that will mean something to your user interface. So they are just becoming more and more complex to test. So the point is, there are numerous scenarios and conditions that must be validated. How in the world are we going to do this with the aggressive deadlines and the target dates we are often given? Our goal is, and it must be, to optimize the testing effort. This is a debate I've had with many people that they mean well, they are passionate about software testing and quality, and they're of the mindset that you should never, ever, ever deliver an application into production with a single defect. But honestly, is that possible? Think about that for a moment. When it all comes down to it, we are doing this for the sake of a business, and that business must be profitable. So at a certain point, our cost due to our software testing efforts start to exceed the cost of what we might realize if functionality fails into production. So in your graph, this says it well. The blue column, that is our testing cost. As we test, those continue to increase. They go up. But the idea is our failure cost, hopefully if we're doing it right and we're finding defects, our failure cost should decrease because we're finding more defects, so we know, okay, that's not going to fail in production, or it shouldn't anyway. But at a certain point, again, our testing cost could end up significantly surpassing our failure cost. That's when it's time to stop. So we want to optimize our testing effort. One thing to think about, true risk comes from not knowing what you're doing. And that's a quote I live by Warren Buffett. I love that, and I live it. So the things to think about when we talk about risk analysis, because we want to get that under control, we want to be able to improve our process so that we truly validate that functionality, which is of the highest impact should it fail, and the highest probability to fail to our organization. So let's talk about a few terms when it comes to risk analysis. So there's asset. So as I discuss and use that term asset, that could mean a requirement, it could mean an application, a system, a use case, a user story, etc. Whatever could possibly fail in production, thus causing a risk to our organization. And then there's impact or criticality, but I'm going to try to stick to the term impact. What is the impact to the organization were the risk to occur? And that impact could be monetary, it could be reputation, Think about the negative reputation caused to so many organizations when a critical IT problem is realized in production, realized by their customers. There's probability, AKA likelihood. And that is, what's the probability that a given event or defect or issue or failure will occur? And the other thing to always think about, just a fact of life, is exposure. So that could be, well, you know what? The thing that makes this such a high impact is the people that it will impact, the importance of those people. Or it could be the number of users involved. So these are things to think about. You've got to think about the exposure to get an idea of how prevalent the issue may be, and thus that could potentially weigh the monetary impact to your organization. So let's talk about the term risk-based. I'm sure many of you have heard that term before, and I'm going to talk about 3 different definitions when you hear risk-based testing. So one approach A is when risks are defined before all else. So imagine, if you will, that all of us, all of you attending and I get together and we say, hey, let's start our own business. And then we say, okay, we're going to start our own business and this is what we're going to sell. We're going to sell this service and this product. Well, we need a website. What's the risk to our organization if we don't develop a website? What are the risks to our organization if we do develop a website? So we define the risk and then we make a decision. So in other words, all assets evolve from the risk, and that is true risk-based approach. You must start very early, at the very beginning, because so many decisions evolve from that risk-based approach. Then there is when risks are defined during the creation of the assets, and you would then map the assets to your risk accordingly. But again, so you've already got your assets, perhaps your website, that's already defined. And then you say, okay, we've got this website with this functionality. What are the risks that we may realize? So again, you are still defining the risk. Now, with approach C, which is what we're going to focus on, we're talking about when risks are implied by assets failing. So the functionality of that website, of that requirement, of that use case, user story, whatever it might be, acceptance criteria. The risks are implied by assets failing. So that is when we're going to perform risk analysis that I'm going to talk more about this afternoon. So the idea there is you will assign risk scores based upon impact and probability. So you're going to ask, hey, if this asset, if this functionality fails, what will be the impact to our organization? And you've got to include direct and indirect. And you've got to ask, what is the probability of this failing? If it's a high probability, then the fact that it's a mid-impact may change things. And remember, I want to emphasize that you want to be sure to take in consideration direct and indirect. So one of the things that I want to share with you is there was a retail organization many years ago that approximately 1 week prior to Christmas, their website crashed. It was down all day. Imagine the revenue lost. Customers were not able to order products off of their website for 24 hours. Well, as you can imagine, that led to a significant revenue loss, because at that point in time, who can wait? You're going to go find somebody else. You're going to go to a competitor and order that product for Christmas. But the thing is, that wasn't the end of it. Naturally, within days of that happening, this organization's value of shares, their share value plummeted. But again, that wasn't the end of it. Months later, the shareholders all got together and sued this retail organization and won a lawsuit for well over $6 million. So again, as you can see, the cost can skyrocket once you take into account indirect cost. Now, the benefits of risk analysis, I want to talk about the benefits of performing risk analysis and the value. So when you perform risk analysis, it enables you the ability to run tests in risk order. It also allows you to allocate your testing effort based on risk. It allows organizations to make much smarter release decisions. Do we really want to release this into production right now? And then number 4, if the schedule requires, you can test in reverse risk order. So in other words, start with the high stuff and then go lower. Now, the value for each of these, by running the test in risk order, it lets you find the scary stuff first. So for those of you in QA and software testers, and if you've been a developer before, you know exactly what I mean. Think around especially the holidays. An application, it's got to be deployed into production on December 31st. You don't want to find out that there is a critical defect on December 29th. It's much better if the type of testing that focuses on critical impacts and high probability, if you start those earlier, the developers will appreciate it if you bring those issues to them earlier in the life cycle. Allocating test effort based on risk. So it lets you pick the right test. Think about the test plans you've been exposed to. Are all of the test and the validation processes simple? No. You've got some very complex tests. But the point is, by allocating the test effort based on risk, you can choose your A team and say, hey, A team, I want you all to validate these tests that we've identified as high impact, high probability, or high impact, low probability. And then perhaps you give the low impact, low probability, you know what, give those to the more junior testers. It's a great learning experience while they get their skills up to speed. It allows organizations to make smarter release decisions. So you can deploy when the risk of delay balances risk of dissatisfaction. So a perfect example, on one project that I had that was heavy into messaging, there was a particular message where we found a defect, where the defect was in the message, instead of having a colon, it had a semicolon. Was the message still understandable with that very small defect? Absolutely. So do you honestly think the end users would have preferred and would have been more satisfied if we delayed deployment until we got that fixed? Or were they willing to take the risk that somebody might misunderstand the message because instead of a colon, it had a semicolon? No, they said deploy it, and we fixed it afterwards. And then in regard to if scheduling requires test in reverse risk order. So in other words, you can give up the test that you worry about the least. Perhaps you have 2,000 tests and you've determined, you know what, 25% of these are low impact, low probability, seldom have they ever occurred in production. We will test these if time permits. And it always makes management happy. If you go to them and say, hey, I wasn't able to test everything, but I tested everything with a high impact, high likelihood, and a high impact, low likelihood. So what you need to do, what you want to do, is develop a risk analysis process. It's got to be a formalized process. 4 steps. First thing you do is create a risk profile. So with a risk profile, you're going to define numeric ratings with detailed descriptions. So the more granularity, the better. It makes it so much easier for everyone to understand, and it helps avoid confusion. It also helps to develop an assessment questionnaire. Straightforward questions that can be answered, which, when answered, basically imply or lead you right towards the score of impact or probability. Step 2, start to assign risk scores to the granular assets, and we're going to focus on those more in just a moment. Compile the risk assessment database. That way, it improves the risk assessment process and it helps management plan development projects down the road, because they can look for similarities that there have been in past projects with the new project, and they can say, okay, well, we used this type of technology a few projects ago and we had these types of issues, these types of risk. We're using that same technology now. That risk may be true here as well. And one of the things you want to be sure to do is revise the risk profile as appropriate. Remember, it's a living document, a living database, if you will. So now let's talk about assigning risk scores. First thing you do is assemble your list of assets. As I mentioned earlier, when I use that term assets, it can be requirements, use cases, user stories, acceptance criteria, whatever it might be. So assemble those, determine what is it that you're going to perform your risk analysis on. Step 2, for each asset, determine the impact if the risk eventuates. So if it actually occurs in production, what will the impact to our organization be? And then for each asset, determine the probability or the likelihood. Now for steps 2 and 3, by the way, I always tend to say do impact first, but you don't have to. If you want to do probability first, that's fine. So it doesn't matter step 2 and 3 if those are reversed. But then for step 4, you then calculate the risk score, combining the risk impact and the likelihood, as well as an optional score for a weight. And I'll be talking about that in just a moment. And I'll be talking about different formulas that you can use. So remember, when we talk about impact, there's loss of life, loss of revenue, inconvenience to the end user, the exposure or frequency that this functionality is performed, thus increasing the impact. There's probability. Is it new functionality? Is it existing functionality? How mature is it? And remember, if it's new technology, we're not talking about new to IT. We're talking about new to your organization. Has your organization ever implemented this technology before? And then optionally, you can define a score for weight. So that's an additional factor that you might take into account and factor into the calculation to more adequately determine the risk score. Now I'm going to show you in just a moment some examples where I use a weight factor for probability, but you can also come up with a weight factor for impact, because think about it, in the impacts right here on this particular slide, if the impact is loss of life, then you might just say, well, hey, you know what? I don't care how unlikely it is that that parachute won't open. I ain't doing it. So the point is, it doesn't matter how likely it is that a failure may occur in production. If loss of life is a potential impact, then we've got to give that and make that the highest priority and make sure we validate that. So here are some other generic risk, and this is just a partial list of different factors that could impact or probability. So perhaps I should say that could influence impact or probability. So is the code complex? So the longer the source code is, the more complex it is. That increases the probability that there could end up being a failure. Is it new functionality? Is it new technology? Has it been changed recently? So these are factors that could influence the probability. Notice that going down a couple, popular. So is it popular functionality, meaning is it used frequently by our end user? And if our end users use that functionality on a regular basis, then that increases both the impact as well as the probability, because numerically that increases the odds that a problem could occur. Is there any upstream dependency or downstream dependency? So you'll notice that the upstream dependency influences impact, whereas downstream dependency influences probability. Has there been a history of issues? If so, then that history will most likely continue unless we're confident that has been addressed in a previous version. Has there been a recent failure? Has that recent failure been resolved to our satisfaction? And then let's not forget a poorly written requirement. That obviously is always going to increase the probability that a failure could occur in production because of a disconnect somewhere along the way. And this, by the way, and I want to emphasize this because so many of you are AQAA. This came from a book written by William E. Perry, who was the founder of QAI back in the day, for those of you that remember. So once you've got these risk scores for impact and probability, I want to share 3 different options that you have in regard to computing the final risk score. One is you could add the scores. So you multiply impact by weight if you have weight. You multiply probability by weight if you have a weight for probability, and then you add the scores together. I personally am not a big fan for that because it is less granular. So in other words, you will find more and more of your high impact, high probability, you'll find everything more clustered. So it won't give you very granular detail. Another option is to multiply the ratings that you give it. So multiply impact by weight, probability by weight, and then once you have that impact and that probability, multiply those together. And then another option is score plotting. That's my favorite. So that's where you multiply your impact by the weight if there is one, probability by weight factor if there is one, but then you plot those on a quadrant. So the 3 steps, you determine the impact, you calculate the probability, and you plot the scores. So the idea is that you have this quadrant where quadrant 4, that's what we're going to focus on first or give to our A team if we have a large enough testing team. Quadrant 4 is the high impact, high probability. We want to tackle those first, and we want to put our best resources on quadrant 4. And then there's quadrant 3. That is high impact, low probability. Quadrant 2, that's what we're going to focus on in step 3. That is the high probability, low impact. And then 4th step in quadrant 1, that is low impact, low probability. So when would you consider, think about this, when would you consider a risk acceptable? And besides risk, what other criteria might impact priority? So you may very well consider a risk acceptable if your end user tells you it is acceptable. I had a situation on a project once where this was back many years ago, probably about 25 years ago, where I was doing some exploratory testing because I strongly suspected something would break the application. And I spent a good 16 hours proving myself right. But then the end customer came and shared with me. But the thing is, Bob, that happens once out of every 2 million transactions. We already know about it. There's an easy workaround. And most of the times, the edits on the front end will keep that from ever happening. So as you can see, I wasted 16 hours of my and their time. So besides risk, what other criteria might impact priority? Well, remember, urgent and high priority don't necessarily go hand in hand. So if you've got aggressive target dates that are approaching quickly, that might impact your priority. That might bump it up the queue, if you will. Also, are there any available, acceptable workarounds for the time being? And what does management, and as I mentioned, the customers have to say about that? So is the risk acceptable? So let me share with you an example of a more complex approach. So I am getting to what I call the rapid risk scoring approach, and I'm going to share that with you at the end. But right now, let me share with you an example. So here you see a list for impact of ratings for impact, i.e. criticality. So notice we've got 11 different values here. 0 for no impact, 1 for minor impact. Let me skip down a little bit to 5. Moderate impact, little monetary loss, workarounds needed. Take a look at number 8, major impact, major loss, no workarounds available, customers notice, right on down to 10. So if you look at these, right away you will see the granularity of these definitions. So it makes it so much easier for others to apply these ratings as long as they know the functionality, the application, and the business to a certain level. Now, naturally, this took some collaboration to come up with, but once they did it, they've got this list and these definitions, so they are on their way to developing this risk analysis database. Then you've got to decide for probability, are we going to have just probability, or are there factors that significantly increase the probability that certain functionality may fail? So that in this example that I'm sharing with you, you'll notice I said, all right, for our organization, we notice that the more complex the source code is, the higher the probability is that there will be a problem. And we give that a weight of 3. Then there's frequency of use. How frequently is this used in production out in the real world? Because we've noticed that the more frequently certain functionality is utilized, the higher that increases the probability or likelihood of failure. So we're going to give this a weight factor of 2. And then we've noticed with new functionality, you know what? We've got a great team. They're eager and they're intelligent and they keep themselves up to date on the latest technology. So we've said we haven't noticed any increase in the likelihood of failure just because it's new functionality. So we're going to give that a weight of 1, which is basically no weight. And then we have said, all right, now our rating is going to be a 5, a 3, or a low. So a 5, 3, or 1 for low. And then we've got that formula down at the bottom where we say, all right, complexity, whatever rating we give that, times the weight of 3, plus the frequency of use times the weight of 2, plus whatever rating we give it for new functionality. We take those scores, add them together, and divide them by 3, and that gives us our probability. So remember, what we're doing here is we're now going to take our impact score, and our probability, and we're going to plot that on our quadrant. So here's a real world example where we've got a shopping cart for the module select items in our payment process application, in our module for credit card payment, and then we've got shipping query in our order queries process. So for complexity, you can see for select items, we've given that a rating of 1, but it's got a weight of 3, don't forget. For frequency of use, because it's used a fair amount, we've given it a 2, frequency of use is 2, and then new functionality, we've given that a 3 because this is new functionality that we've introduced. So you can see that once we take these scores, we then come up with our probability score. We go through and identify our impact score. So you can see the payment process, which I'm sure makes a lot of sense to all of you, is that which is considered the highest impact to our organization. And we then plot those on a quadrant. So this helps visually take a look. Now, this is a long time consuming process, which is why I realized, you know, in Agile and in DevOps or CI/CD, there is no way in the world any organization is going to be able to do this unless they've already had this process in place for years. So that's why I've come up with a rapid risk scoring process. So this is much like the poker planning. So the idea here is you get a team or designated group together. Each individual gets a card with scores of, and you can use whatever, you can use 1 through 5 if you want. So here I've got 1 through 4, and it goes 1 low, 2 medium, 3 high, 4 is very high. Again, you can go more granular if you want. The idea is once everybody has these cards, a spokesperson, perhaps the scrum master, the leader of the team, will get up and describe the asset with a similar type of description for each. So is it new functionality? What kind of exposure do we have? Have there been any problems in the past? Is the code complex? And you give each person 5 seconds to hold up a scorecard for impact, 5 seconds for probability. So you literally say in your meeting, in your stand-up, 1, 2, 3, 4, 5, boom, everybody throws up the rating. You average the scores, and that gives you your impact and your probability. And you then plot those on your quadrant. Now, so let me show you, and if we were face-to-face, I've done this numerous times in classrooms, and it is absolutely amazing because it uses the psychology of wisdom of the crowd. You and your team know so much about your business and your applications perhaps than you realize. So in this example, we've got a login process. A user can successfully log in with a valid username and password, but there is no customer service phone number displayed until they log in. It's mature functionality, and it is performed more than 12,000 times a day. So with that brief description, would you rate the impact if this login process were to fail? Would you rate the impact as low, medium, high, or very high? 1, 2, 3, 4, 5, hold up your hand. And it's absolutely amazing because when I do this in sessions, in live sessions, approximately 90% of the students will all give this an impact of 4, with the remaining 10% by far being a 3. Then would ask about the probability. And I would say 1, 2, 3, 4, 5. And then in this example, approximately 80% give this a 2, while the others will give it a 1. And that's because of the mature functionality. But most will give it a 2 because of the fact it's performed so many times compared to our other processes.
Bob,
And
we have an interesting question, if you don't mind.
I'd love it. Sure.
So when going through this exercise, Michael wants to know, how do we determine the probability of a problem if we have not experienced it?
So great question. So what you can do there is speak to your end users, get that type of business knowledge, make sure you understand what the legacy is. You can take a look at the defect logs to get an idea of the probability of a problem. So
as well as the impact.
correct, as well as the impact. It will help. That's absolutely right, as well as the impact.
Great.
So you need to have a certain level of business expertise, but you don't need to be have as much expertise as the end user, because so many processes out there, we can relate to, and we understand what they are doing, but it definitely, what I do recommend is get a team of 5 to 10 people to do this, and do choose those that know the most about the business, the application, and the processes. Absolutely. Any other questions, Glenn?
Not yet, but I'll remind folks to go ahead and type them in, questions into the question window.
Great, great. So then on product search, you can see that the functionality per product search, it provides detailed product info and competitive comparisons. You can call into customer service once you've logged in and you're at the product search functionality. It is new technology, and it is performed 8,000 to 9,000 times per day. So again, think about this for just a moment, and let's talk about impact for a minute. On 5, play along with me if you will, pretend we can see each other. On 5, what would you rate this for impact? 1, 2, 3, 4, 5. Now in this particular example, approximately 80% of the students, when I give this example, 80% will give it an impact of 4. Thinking, okay, if they do a search and they can't find the product, then maybe they don't have it, they're not going to buy it. With the other 20%, most of them being closer to 3. And their thought usually is that it doesn't have to do direct with money exchange or payment. So the other thing that you can do when this helps spur discussion. So in your meetings when you're doing this, you can always eliminate one of the highest scores and one of the lowest scores. But the thing that you want to make sure you do is don't eliminate those scores without discussion. And ask those individuals, that's interesting, you're one of the few that gave this a 1. Why did you give it a 1? In case they know something that you don't. It is important, again, when the moderator, Scrum Master, whomever it is reading through these, it is important that they be neutral so that they do not attempt to influence the team for doing this scoring. So then there's the same thing for order checkout and product return. For product return, if you look at that, it includes process payment refund. You can call customer service if you have a problem because you are logged in. Mature functionality, stable history, performed 100 to 500 times per day. So in this, when giving this particular functionality in classes, I found that 90% will give it an impact of 2. So they'll hold up 90% of the classes. And my classes usually have anywhere from 25 to 35 students. So again, it's the whole wisdom of the crowd. Now, without a doubt, I will tell you one of the drawbacks or disadvantages is when there is functionality that is extremely abstract. And what I mean by that is if I were to hold up this pen and say to you, how many test cases could you write or design, or how many user stories, how many could you design for this pen? Well, if you were to give me any sort of number, you'd be wrong. Because the first words out of your mouth should be, well, Bob, what are you going to do with that pen? Are you going to stab it in the wall? Are you going to, what are you going to do with it? Don't assume I'm going to use it as a writing utensil. So apply that, use that thought to, if I had a brick, I mean, a brick would be very abstract. There's so many things we could do with it. Use it as a weight, use it to break something. So the more abstract functionality is, that's when this, without a doubt, does become more challenging. Another thing that you could do, Glenn, back to that question that was just asked, and that was excellent, is, and on the FBI project, we had this luxury. In part of our team, we had several end users and customers who would educate us on the processes. So they were also part of these types of rapid risk exercises.
So in that case, it helped to have an external subject matter expert.
Exactly right. Any other questions, Glenn? I'd be happy to take more questions. We have about 10 minutes.
Yes, we do. So we have one. These are both anonymous. The first one is says, "Great talk. Makes me think of grading assets like tests, defects, etc. What are the best tools that you could recommend for that?"
So there are certain tools, all the tools I'm familiar with, and my organization, we're partners with Tricentis, we're partnered with Microfocus, we have a lot of Atlassian expertise. If they don't have some sort of risk analysis functionality already built in, then they are easily customizable. And, a lot of those solutions I like quite a bit. I mean, one of the things I know with ALM and ALM Octane is you can include traceability as well as dependencies upstream and downstream, and that helps a lot. But I also know for a fact that Qtest, Jira, if you're on that, can easily, workflows can be developed for that type of capability.
Okay, great. We also have a question from Stephen. With many of these criteria being time-based, new versus mature, history of failures versus no history, how do you update these risk assessments, and how often is that update performed in an agile environment?
Oh, great question. Great question. So I would say at least every 2 months. Monthly would be ideal. So, because here's one of the things, the more frequently you can do it, well, it's just like Agile. I mean, think about it. For those of you that remember Waterfall, we tested just as much in Waterfall, but it seemed like we tested a lot more because we had fewer test iterations. So we were running thousands and thousands and thousands of tests maybe every year. Now, with Agile, we're cranking fewer tests, but a lot more frequently. So we're doing it rapidly. So same idea is you prevent it from growing into this massive effort by tackling it more frequently and keeping it clean. So you're not hoarding, in other words. Does that make sense?
Yes, excellent. We have another question. What are some examples of how QA teams apply this risk tracking?
So one of the things is that they will typically do is they will take their, you've heard me mention, I think the most often use cases, user stories, and requirements. But the other thing they'll do is they'll take test cases. So if they don't have well-documented requirements, then they may look at a test case and say, okay, if this test case fails in production, well, basically that means that the functionality or features, whatever it might be, fails in production. What will the impact be? And they will perhaps create a user-defined field for impact and probability, thus giving it a final score. And they're able to not so much plot it on a quadrant, but then create a report saying, okay, show me all of my high impact, high probability functionality as specified in my test cases. So test cases, use cases, user stories, requirements, those are the 4 assets I see this applied to most frequently by a quality assurance and software testing team.
Excellent. All right, we do have a question that just popped up from Ivan. So assuming you have 2 projects, one that's very bug-ridden and fragile in that the fixes that you try to implement themselves cause other bugs, and another one with occasional issues but has very stable fixes, what would be the difference in your approach to evaluate risks between those 2 projects?
Oh, great question. So one of the things I would make sure that I knew was the impact, the priority, the strategic direction of each of the different projects, and then the impact if either project holistically should fail, as well as the different functionality and business processes if those should fail within the project. That would heavily influence. All things being equal, if I believe you said Ivan asked that question, if
Yes.
the project that were to have the most likely number of failures, which you said could cause others. So if the impact of all the features, both applications are equal, that's the one I would target first. Because by tackling that, in my mind, it's like, okay, we're going to end up preventing more work for us down the road. So let's try to cut that off at the pass.
Okay, sounds good. We don't have any open questions right now, so give folks a moment or two to type them in. I do have a question coming from an Agile background. It seems that the risk assessment, the success of it, is something to really reflect on during perhaps a sprint retrospective.
Absolutely. Great point, Glenn. It's, this should definitely be part of your retrospective. Do a lessons learned, constantly be improving this process without a doubt. That's a great point. It absolutely should be.
Great. I don't see any other questions in the queue right now.
All right. Well, I have all of my contact info up here as well as on social media. Would absolutely love to hear from any and all of you, not only with any questions, but with your thought. Or thoughts, plural. I'm sure you have more than one. But I'm a firm believer that all of us are smarter than any one of us. So thank you so much for having me. Thank you, Glenn. And everybody, please stay safe and well.
Great. Thanks, Bob. We appreciate it.